Hi guys, welcome to my channel Subhas classes. In the previous class we had already finished counting principle, its applications in different problems in the first exercise. Whether you follow NCRT book or the Elements of Mathematics book or the book by R.D. Sharma or Agrawal, this idea, the idea of counting principle is enough for the first exercise. Let us go for permutations. What are permutations? Permutations are calculating the number of different arrangements that can be made out of any number of things. Suppose I take three things, say A, B and C. These are three alphabets. How many single letter objects I can take? I can take A, B and C. There are three arrangements. Suppose there are three persons A, B and C. I call one person once, one person a time. So how many ways I can call all of them? I will call A first, then B, then C. So the total number of persons will be finished when I have taken three of them. So the number of different arrangements that I could make using three, there were three, and every time I took one. So this is a kind of permutation. P31 is 3. Why? Because out of the three objects, when I took every time one only, I finished the set of three things in 3 steps. So the possible arrangements were 3. What if I take 2? P32, permutation of 3 things taking 2 at a time. I take A and B, next I take A and C. I can also take B and A, next B and C. I can take C and A and also C and B. So the total number of choices I have is AB, AC, BA, BC, CA and CB. So total number of choices are 6. I can count them like this: AB, AC, BA, BC, CA and CB. See, there are 6 in all. So P32, permutation of 3 things taking 2 at a time, will be 6. And what if I take 3 things at a time? When I take P33, how much they will be? How many possible arrangements they will be? Let us check. I can take A first. For the second choice I take B, and I have only one choice left, so A, B, C. If I take A first but not B, instead I take C, then I will have A, C, B. So I have already got two sets when I have chosen A for the first. If I choose B for the first, there will also be 2 choices. You can see them. I take first B, then C and A, or then A and C. So in this way also I get 2 more. If I take the C as the first choice, what will my next 2 choices? The 2 choices can be A, B or B, A. So what are the choices? The choices are ABC, ACB, BCA, BAC, CAB and CBA. In all there are 6 choices. So P33 is 6. Permutation of 3 things taking 3 at a time is 6. So can we take another way to find the same? Can we look at the same solution in a different way? When I take permutation of 3 things taking 1 at a time, this becomes 3. When I take permutation of 3 things, then there are 3 things. I am taking 2 at a time. So I have 2 places. I can take 2. So for the first seat, I have 3 choices. And when I have already chosen 1, then 2 are left. So there will be 2 choices here. Do you understand this problem? Suppose there were 3 girls, G1, G2 and G3. and they had to choose their husbands from 2 boys. So how many marriages can occur? How many choices can occur? Girl 1 has 2 choices, B1 and B2, and boy 1 has 3 choices. So B1 can be chosen by anyone out of these 3 in 3 ways. After B1 is chosen, someone has chosen, so the choices left for the second boy will be 3 minus 1. So the first one has 3 choices, the second one has 3 minus 1 choices. So we can write this 3 into 3 minus 1. And what about the 3 things? If there were 3 girls going to opt 3 boys to choose their choices from bridegrooms from 3 boys, then what would be the number of such cases? For the first, there will be 3 choices. The first boy can be chosen by any one of the 3 girls. So B1 has 3 choices. After the B1, the boy is chosen, the first boy is chosen. Now the boys left are 2, and in this case, one girl has already chosen. So there are 2. So for this, there are 2 girls, and after the second boy is also chosen, the boys left is 1 only, and the girls left will also be 1. So 3 into 2 into 1, we can write this as 3, and after the first choice 1 is reduced, the choices reduces by 1, and for the second choices reduced by 2. So this is the formula what we expected. We can write now P, this is 3, this is 3 into 2, and this is 3 into 2 into 1. So now we find this is also written as 3P1, or permutation of 3 things taking 1 at a time. This is equal to 3. 3P2 is 3 into 3 minus 1, and 3P3 will be 3 into 3 minus 1 into 3 minus 2. Now you can say what will be NP3. If 3P3 is 3 minus 1 and 3 minus 2 multiplied, then this will be, the first choice will be n, the second will be n minus 1, the third will be n minus 2. Now we got a formula. So if we are asked, say 11P5, the first choice will be 11, the second will be 11 minus 1, so 10, the third will be 11 minus 2, so 9, the fourth will be 11 minus 3, so 8, and the last one will be 11 minus 4, so 7. We can write also in the formula 11 into 11 minus 1 into 11 minus 2 into 11 minus 3 into 11 minus 4. So see, the fifth choice is always minus 4, contains minus 4, fourth choice minus 3, third choice minus 2, second choice minus 1, first choice minus 0. This can be written as 11 minus 0 into 11 minus 1 into 11 minus 2 into 11 minus 3 into 11 minus 4. Just I am converting this expression into a different form also, because it is the first choice, it is the second choice, it is the third choice, it is the fourth choice, and it is the fifth choice. So these numbers should be involved in the formula. So I write them as 11 minus 0 is 1 minus 1. The second one, 11 minus the value is 2 minus 1. Third, 11 minus 3 minus 1. Fourth, 11 minus 4 minus 1. And fifth, 11 minus 5 minus 1. So now we got a formula for 11P5, and now perhaps we can write the formula for NP5. The first one will be n minus 1 minus 1, similarly, because n is replacing 11, and the second will be n minus 2 minus 1, then n minus 3 minus 1, then n minus 4 minus 1, then n minus 5 minus 1. So if now we replace 5 by another number r, we get a formula npr. What will it be? The first one clearly, this is n minus 0, this is n minus 1, and the last one is n minus 5 minus 1, which we can write n minus 5 plus 1. So in this slide we can write this as n minus 1 plus 1, first one. The second is n minus 2 plus 1. The third is n minus 3 plus 1. The fourth is n minus 4 plus 1. And the fifth is n minus 5 plus 1. We do not calculate, just we mention the pattern. Now NPR you can write, first one will be n minus 1 plus 1. Second will be n minus 2 plus 1. Third will be n minus 3 plus 1. Can you tell me what will be the 10th? What should be the 10th? If third is n minus 3 plus 1, 7th should be n minus 7 plus 1, 10th should be n minus 10 plus 1. So what will be the rth? What will be the 100th? It will be n minus 100 plus 1. And if that is the r plus 1 term, then it will be n minus r. This is the rth term. So what is the term actually? N minus r plus 1. See, you will have to write n minus r plus 1 only when this is n minus r minus 1. So the 1 minus 1 was the first term, 3 minus 1 is the third. So when here r minus 1, this should be the rth term. So when you have r choices, if you have to take totally, there are n things you have to choose r at a time, then this will be the expression. So let us take the formula like this: PNR or NPR is product of n r consecutive numbers. The first number is n, second is n minus 1, third is n minus 2, and this way the last term will be n minus r plus 1. This is the formula of PNR, NPR. And what if we try to find NN, PNN or NPN? So we have to start with n and gradually decrease by 1 every time, and keep decreasing till we have decreased n things. In the second we reduce by 1, the third reduce by 2. So the nth term will reduce by n minus 1. See, the last one should be n minus 1. Here it was also n minus r minus 1. So this will be n minus 1, which is 1. So this will be n into n minus 1 into n minus 2 up to like 5, 4, 3, 2, 1. So this is product of n consecutive numbers. This is in another term is known as factorial n, written in two different ways, called factorial n. So what is factorial n? It is the product of n numbers starting from 1 to n or n to 1. If it is in ascending order, you can write 1, 2, 3, 4, 5 up to n minus 2 into n minus 1 into n. This is n factorial, and in the descending order this is n into n minus 1 into n minus 2, and the r plus 1 term n minus r plus 1, and likewise the last few terms will be 3 into 2 into 1. This is also n factorial. Now we can deal with some more problems using the idea of n factorial. If this is n factorial, then how much is 5 factorial? That is 5 into 4 into 3 into 2 into 1. We are taking 5 different objects, each one reducing by 1, and this is 120. What will be 4 factorial? You see, 4 into 3 into 2 into 1, which is 24. So can't we write 120 as 5 into 24? 5 and the remaining 4 can be 4 factorial. So this can be written as 5 into 4 factorial. And this can also be, when we find out 3 factorial, it is 3 into 2 into 1, which is 6. So this can also be written as 4 into 6, which is 4 into 3 factorial. And 6 similarly can be written as 3 into 2 factorial. So what finally we get, 5 factorial can be 5 into 4 factorial, or 5 into 4 into 3 factorial, or 5 into 4 into 3 into 2 factorial, or 5 into 4 into 2 3 into 2 into 1 factorial, which is also 1. So we got another thing, 1 factorial is 1, and also we have to prove 0 factorial is 1. How to prove it? For this we have to find the Npr formula once again. We have already found that Npr is n into n minus 1 into n minus 2 up to n minus r plus 1. And if I just do not stop here and continue going up to 1, suppose I continue reducing every time by 1, then I have to write n minus r, then n minus r minus 1, and in this process finally I will stop at 3 into 2 into 1. And but in the previous expression it was up to n minus r plus 1, means up to this. So what have I taken more, which was not there, the factors from this to this. So let me divide those factors here so that it retains its original value. See, if these factors are cancelled, then we get the factors which are just equal to this. So now the numerator is the product of n things from n to 1, so it will be n factorial, and the denominator will be starting from n minus r, it is up to 1, so it will be n minus r factorial. So we got the formula for Npr. Apart from this, this is the formula which we derived, and this is the formula 2. So there are two different forms. Now you see, what if I use, what when I use Npn in this formula, it will be n factorial divided by n minus n factorial, which is equal to n factorial by 0 factorial. And you also know that in this structure Npn is product of n consecutive things, taking out of n things we are taking all at a time. So n into n minus 1 into up to 3 to 1. So this is equal to n factorial. So if Npn is n factorial by 0 factorial and Npn is also n factorial, then these two are equal. That means n factorial by 0 factorial is n factorial. That means n factorial is n factorial into 0 factorial. So what should be the value of this one? If you multiply something and you get the same thing, that is the multiplicative identity 1. So this proves that 0 factorial is equal to 1. So we got 0 factorial is equal to 1, 1 factorial is equal to 1, and we have already decided all the formulae that the chapter permutation contains. So with these formulae we will solve the problems in the exercise in the next class. In this class we have already cleared the how the formulae came, what is Npr, what is Npn, what is 0 factorial, what is 1 factorial, what is n factorial, and how these things come into being. If you like this video, please share it and subscribe my channel Subhas Classes. Till then, bye. Thank you.